The valley floor trembles, not from an earthquake, but from a frequency so low, it rattles your ribcage before you hear the sound. Then, the roar arrives. A grinding, mechanical scream like 1,000 locomotives derailing at once. You look upstream, expecting the blue clarity of a mountain river, or perhaps the white froth of rapids. Instead, you see a churning wall of opaque, chocolate-colored destruction. It does not splash. It hammers. A 2-story home, built with steel-reinforced concrete, stands in its path. In a fraction of a second, the structure doesn't just flood. It shears off its foundation as if cut by a guillotine. The brown liquid strikes with the density of wet concrete, crushing a family car flat against a tree trunk, in the blink of an eye. This isn't water anymore. It is a geological event accelerated to highway speeds. This is the liquid earth reclaiming its territory. Why is the water brown? It is the color of the weapon that is about to erase everything you know. Let's find out. Most turn away. But here at Surphysia, we decode the math behind the chaos. Support the mission by subscribing now. To understand why floodwater turns brown, and why that change in color signals a catastrophic increase in deadliness. We must strip away our romanticized view of water. We tend to think of water as the life-giving, translucent liquid that comes out of our taps, with a density of 1,000 kilograms per cubic meter. But the brown torrent tearing through a canyon is not water. It is a hyper-concentrated suspension. A non-Newtonian fluid that defies the simple fluid dynamics taught in high school. When a river surges and turns that characteristic churning brown, it has undergone a phase change. It has transitioned from a fluid that flows around obstacles, to a fluid that flows through them. The color brown is the visual data representing mass. It indicates the presence of suspended sediment. Silt, clay, sand, and soil. But this is not merely a dye. It is a fundamental alteration of the physical properties of the liquid. In a clear flood, the water might exert a specific pressure based on its velocity and depth. But as the water accelerates across the land, stripping away topsoil and eroding banks, it begins to bulk. This process, known as bulking, dramatically increases the density of the flow. Consider a cubic meter of clear water. It weighs exactly 1 ton. Now, look at that brown, turbulent wall. That is a slurry. By volume, it can be up to 60% solid matter. A cubic meter of this brown fluid can weigh nearly 2 tons. Twice the mass of clear water. When we plug this into the kinetic energy equation, kinetic energy equals 1/2 mass times velocity squared. We see the terrifying reality. Even if the speed remains constant, doubling the mass instantly doubles the destructive energy. The brown color is your warning, that the river has just equipped itself with a sledgehammer twice as heavy as before. Let's zoom in to the microscopic level. Right at the boundary layer where the water meets the soil. This is where the color is born. As rain hammers the earth, or as a river breaches its banks, the sheer stress of the moving fluid overcomes the cohesion of the soil particles. The water molecules, driven by gravity and pressure, act like billions of tiny pry bars. They wedge themselves between grains of sand and platelets of clay. Clay particles are particularly insidious here. They are microscopic, often less than 2 micrometers in diameter. Finer than the edge of a razor blade. Because they are so small and carry electrical charges, they don't just sink. They remain suspended, held up by the turbulence of the water. This creates a colloidal suspension. The water becomes thick, viscous. It loses its ability to splash and gains the consistency of a milkshake or wet cement. This viscosity is crucial. In clear water, turbulence dissipates energy. In this brown sludge, the viscosity dampens the turbulence just enough to create a laminar, plug-like flow in the center of the channel. This plug flow moves as a solid unit, carrying immense momentum without dissipating it through internal friction. This is why you see large boulders floating in brown floodwater. It defies intuition. A boulder is denser than water. It should sink. But in a hyper-concentrated mudflow, the fluid density is so high, and the buoyant force so magnified by the suspended mud, that rocks the size of small cars become neutrally buoyant. They bob along the surface like corks. This adds a secondary element to the destruction. The battering ram effect. That brown water isn't just liquid. It is a conveyor belt of solid projectiles. When that brown wave hits a bridge support, it isn't just the fluid pressure striking the concrete. It is the impact of thousands of tons of suspended rocks and debris, hidden beneath the opaque surface, slamming into the structure at 40 kilometers per hour. Let's break down the impact force. Imagine a standard residential wall. If hit by clear water moving at roughly 10 meters per second, the dynamic pressure is severe, likely causing structural failure. But replace that with our brown, sediment-laden sludge. The density has doubled. The viscosity has increased, meaning the fluid doesn't splash away upon impact. It sticks and pushes. The force exerted on that wall is now equivalent to being hit by a freight train. The brown water possesses a grinding power known as corrasion. Mechanical erosion. It acts like liquid sandpaper. As the floodwater moves, the suspended sand and silt scour the landscape. We aren't talking about slow erosion over centuries. We are seeing geological epochs of erosion happening in seconds. The brown color is the land itself being liquefied. As the water rushes over asphalt, the abrasive sediments grind the road surface down. It strips the bark off trees, then the wood, then snaps the trunk. The noise you hear, that deep, guttural roar, is the sound of millions of rocks grinding against the riverbed and each other. A planetary-scale milling machine pulverizing the earth. Let us analyze the chemistry of the brown. The specific shade tells a story of the geology upstream. A reddish-brown hue indicates high iron oxide content, likely from weathered tropical soils or clay-rich hillsides. A grayish-brown suggests a high load of ground-up rock flour, perhaps from glacial deposits or limestone. Dark, blackish-brown often points to organic matter. Topsoil rich in carbon. The most fertile layer of the earth being stripped away and sent to the ocean. This is a tragedy of resources. That brown color represents the agricultural future of a region being washed away in a single afternoon. But the danger of the brown water extends beyond the impact. We must consider the aftermath, the deposition. When clear water floods a basement, it eventually recedes, leaving things damp. When brown water floods a basement, it brings the earth with it. As the velocity of the water drops to zero, the turbulence can no longer support the massive load of sediment. Gravity takes over. The mud settles. This settlement process creates a phenomenon called concrete setting. The fine silt and clay particles pack together tightly as the water drains away. In many cases, this mud can harden to a consistency resembling low-grade mortar. Rescue crews often find cars completely encased in this material, turning excavation into an archaeological dig. The brown water doesn't just damage property. It entombs it. The weight of this residual mud is staggering. A layer of flood mud just 30 centimeters deep in a standard living room adds tons of dead load to the floor joists, often causing buildings to collapse days after the floodwaters have receded. The physics of this flow also explains why brown water is so impossible to swim in. In clear water, a human can generate lift and propulsion. But in a mudflow, the viscosity is too high. You cannot kick against it effectively. The fluid absorbs the energy of your movement without providing the reaction force you expect. Furthermore, the density changes your own buoyancy. While you might float higher due to the fluid's density, the turbulence, and the roll waves, pulses of higher velocity mud that travel on top of the flow, force you under. Once submerged, the opacity means zero visibility. You are blind, tumbling in an abrasive slurry that fills your lungs not with liquid, but with solid earth. Asphyxiation happens rapidly. Not just from drowning, but from the physical blockage of the airway by mud. Now, let's look at the grand scale. The hydrogeomorphology. The brown floodwater is the primary mechanism for landscape evolution. We tend to think landscapes are shaped by the gentle, day-to-day flow of rivers. This is false. The majority of geological work, The carving of canyons, the moving of deltas, happens during these violent, groundwater events. The capacity of the river, which is the total amount of sediment it can carry, scales exponentially with velocity. A small increase in speed results in a massive increase in the river's ability to turn brown, to eat the earth. When we see that brown stain spreading across a floodplain, we are witnessing the transfer of potential energy from the mountains to kinetic energy in the valley. The sediment load actually reduces the friction on the riverbed in some cases, creating a self-lubricating effect that allows the flow to accelerate even further. It is a feedback loop of destruction. The faster it moves, the more sediment it picks up. The more sediment it picks up, the denser it becomes. The denser it becomes, the more force it has to scour more sediment. The river creates its own ammunition. Consider the heat. The friction within this churning mud is so intense that in extreme events, like volcanic lahars, which are essentially superheated mudflows, the temperature can remain lethal for weeks. But even in a cold rain-driven flood, the internal friction generates measurable heat. The collision of billions of particles generates a vibrational energy that contributes to that terrifying acoustic signature. The roar that sounds like the earth is tearing apart. Because, quite literally, it is. The opacity of the water also hides the toe of the flood. In a clear flood, you can see the rising level. In a sediment-laden flash flood, the leading edge is often a snout, a tumbling wall of boulders and timber mixed with the thickest, driest mud. This snout has high friction with the ground, causing it to move slower than the fluid behind it. This causes the fluid to pile up, building higher and higher pressure until the snout breaks, releasing a sudden, catastrophic pulse. This is why brown floods often arrive in waves or surges, rather than a steady rise. You might think the worst is over, only to be hit by a secondary pulse released by a temporary dam of debris and mud bursting upstream. We must also respect the sheer suffocating nature of the brown water on the ecosystem. Fish cannot survive this. The suspended solids clog their gills instantly. The dissolved oxygen levels plummet because the organic matter in the brown sludge begins to decompose rapidly, consuming all available oxygen. A process known as high biological oxygen demand. The river becomes a dead zone, a moving hypoxic grave. The brown color signals the temporary death of the aquatic ecosystem. Human hubris leads us to build levees and concrete channels, thinking we can contain this beast. We calculate for the volume of water, but we often forget to calculate for the volume of the mud. We forget the bulking factor. A channel designed to hold 1,000 cubic meters per second of water will overflow instantly, if that water becomes a mudflow carrying an equal volume of sediment. The volume doubles, the level rises, and the levees are breached not by water, but by the displaced volume of the mountains coming down to visit the valley. When you look at a glass of chocolate milk, you see a stable suspension. Scale that up to a river 300 meters wide and 10 meters deep. Imagine the chocolate particles are rocks the size of watermelons, and the milk is moving at 20 meters per second. The energy contained in a single cubic meter of that flow is enough to crush a human body. Now imagine millions of cubic meters passing every minute. The brown color is a signal of saturation. It means the water has picked up everything it possibly can. It is running at maximum efficiency for destruction. It is the visual signature of a fluid that has maximized its density and minimized its mercy. It is nature executing a reset protocol, scrubbing the land clean with a mixture of its own soil and the relentless gravity of the planet. So, the next time you see footage of a flood, and the water is that deep, opaque, roiling brown, do not mistake it for dirty water. Respect it for what it is. Liquid land. It is a landslide that has learned how to flow. It is a mixture of solid and liquid that combines the crushing weight of rock with the fluidity of the ocean. It is the ultimate heavy weapon of the natural world. The universe is full of chaos, but we are here to decode it. Stay connected to Surphysia.